Hello, year 10s. So we have done already distance time graph, speed time graph, SUVAT equations. So from there we are moving on to forces. So this presentation is just it's just a sort of a recap of what you had already done in your year 8, I think. So most of the things should be familiar to you. So we are recapping on forces in this lesson, and then we will move on to Newton's laws. Okay, so let's start. So what we are going to see in today's lesson is the different definitions or different explanations of forces. Then we will see the different examples of forces around us. And then finally, how to differentiate between mass and weight. So the first thing is, what is force? So you have in your mind, you have a rough idea. Many of you might be having a very clear idea of what forces are. So think about your definition of force and see whether what you thought in mind matches with any of the ones that I'm going to show you now. Okay, so are you ready? 1, 2, 3. So what is force? Now hold on a second. I know immediately you have taken your pen and you have started writing. So first listen and then you can write. Okay? Some of you are still writing. Okay. So what is force? Force is a push, a pull, a twist. All these are examples of forces. Then what are the things that force can do? Force is something that increases speed. That is what we call as acceleration. Force is something that decreases the speed, deceleration. So a very classic example for this is driving a car. When you're applying the accelerator, you're applying a force which is increasing the speed. When you're applying the brakes, again, you are applying a force which is decreasing the speed. Then the steering wheel. When you're turning the steering wheel, again, you are applying a force which is changing the direction. And then last one, changing the shape. So say you have a piece of paper with you, you're crushing the paper. So you're applying a force and changing the shape of the object there. So these are the different perceptions of forces. Okay, so now those who are listening to this video, pause the video, take down the notes if you want. I know even though I asked you to stop twice, most of you, there will be still some of you who would have continued and copied it already, isn't it? Am I correct? Okay, let's move on to the next one. Now I want you to take 30 seconds and write down the examples of forces, the examples that you can remember of. Okay, so which are the different type of forces that you can recall? And you have 30 seconds now. Think about all the different type of forces you have come across so far. That's 20 seconds. And time up. So I hope you have at least 3 or 4 forces written down. Now I'm going to show you the example of forces, and then the ones that you had not written down, you can make a note of that. So what are the different examples of forces? I think most of you should have thought about gravity or gravitational force. What else is there? Electromagnetic force, then friction. Anyway, let's see the examples. So we have magnetic, electrostatic, gravitational, nuclear. And then you have tension, friction, reaction, upthrust, drag, air resistance, lift, thrust, compression. Okay, so these are the different examples of forces. Now, I have written this as 2 bulleted points. Is there a particular reason that I have put magnetic, electrostatic, gravitational, and nuclear together and everything else separately? Can you think about any reason, any pattern for that classification there? And let's wait and see. So I'm going to go further into the slides. Now, what I'm going to give you is a small activity to see if you can rightly match the forces with their properties. So you have 4 forces mentioned here: magnetic force, friction, compression, and tension. And on the other side, you have some classifications explained there. So again, what we are going to do is I'm going to give you 30 seconds to see if you can match correctly the ones with the right explanation. So your time starts now. Four types of forces and their explanations. 15 seconds done. We're almost there. And yes, we are there. So magnetic force, which one is it? The force that enables the compasses to work. Friction. Which one is friction? The force you get when 2 material rub together. Compression is either in the name itself, the force you get when a material is being squashed. And the last one, the force you get when a material is being stretched. Okay, so let's continue with the other forces. So now we have 4 more forces and 4 explanations. Like the previous slide, 30 seconds and your time starts now. This one is much more easier than the other one, isn't it? Halfway through. Some of them are there in the name itself. We're almost there. And yes. Okay, so the first one is gravity. And gravity is the force that exists when between all objects with mass. Nuclear, that's there in the explanation, that word itself is there. The force that holds the particles in a nucleus together. Air resistance, again, you can see a similarity there. The force you get when an object moves through air. And of course, the one that is left, electrostatic, the force you get between 2 charged objects. Okay, so we are moving on to the classification of forces next. You saw examples of forces. You saw the effects of forces. And now we are moving on to the types of forces. Types of forces in the sense, not the examples of forces. We are going to classify the forces into 2 groups. So I said we will be classifying forces into 2 types. So this should not be new to you. I think you should have done this in year 8, which is, I know it is once upon a time, isn't it? But definitely you have done this. The 2 types of forces are, or the 2 main groups of forces are, contact and non-contact force. So how do we define them? If 2 objects or materials need to be touching for a force to have an effect, then you call it a what force? Yes, a contact force. And among the different examples we saw now, which are our contact forces, think about it. The things have to be the objects have to be actually touching each other to experience that force. Think about gravity. Do you have to, the earth exerts that force on you, right? Do you have to be in contact with earth in order for you to experience that force? No. If you're throwing an object from a window on the second floor, the object will go down, isn't it? It's not in contact with the earth. So gravitational force should not be a contact force. Then what are the two examples, two or one example of contact force? Think. Did you get any? I'm going to show you a couple. Friction, air resistance. Friction will act only when two objects are rubbing each other or are in contact with each other. Similarly, air resistance is when you're moving through air, the air particles will be hitting your body. So they have to be in contact. So similarly, if the two objects or materials do not need to be in touch, then what they have is a non-contact force. So I have already given you an example for non-contact force just now, which is gravity. Like that, think about a magnet and a magnetic material. When you take a magnet closer to a magnetic material itself, you can see the effect, can't you? So that is also an example for non-contact force. Same electrostatic for charges also. In order for them to attract or repel, they don't have to be in contact with each other. Okay, and then one more example is nuclear. For a nuclear reaction to happen, it doesn't have to be in contact with each other. And now I'm going to ask you a couple of slides back. If you look, when I had asked you for the examples of forces, I had given it as two separate bulleted points. And I asked you, can you see a pattern? Can you see a reason why I have linked some forces together in one bulleted point? Now can you see the reason? So the first bulleted point there was gravitational, electrostatic, magnetic, and nuclear. So what did I do there? I clubbed all the non-contact forces together and I clubbed all the contact forces together. So that was the reasoning behind my classification in that slide. Okay, so we are moving on. In all these forces, one type of force, contact force, which is friction, is quite an important force. We will be coming across that term quite a lot in physics. So just a little more detail about what friction is. So a very classic example, or this most simplest example for friction, is you're rubbing your hands together. Okay. Now, when you're rubbing your hands together, after some time you can see that your hand is getting heated up. So what is happening there? What type of force are you producing when you're rubbing your hands together? The answer is yes, friction. Then, so when you look, your hand looks really smooth, isn't it? So normally we say friction happens when we rub two rough surfaces together. So for many of you, it will be like, oh, my hands are so soft. Then why is it creating friction? Your hands looks smooth on the macroscopic level. So when you're looking at with your eyes, yes, it looks smooth. But if you look with a microscope, it is not. So at the microscopic level, your hand is not smooth. It will still have lots of irregularities on it. That is why when you rub your hands together, we get friction. Friction is due to the irregularities in the surfaces of the two substances you're rubbing together. So the most important thing regarding friction is mainly drawing the direction of friction. It becomes really useful when they ask you to draw these free body force diagrams, which we will look into later. So the direction of friction is an opposing force. In the sense, friction is a force that always opposes motion. So if I'm moving forward, friction stops me from moving forward. which means, or friction tries to stop me from moving forward, which means it will be acting in the opposite direction. So the direction of friction is always opposite to the direction in which the object is moving. So keeping this in mind, for the following objects, they have already shown you the direction in which the object is moving. So you need to show the direction in which the force of friction is acting. Okay, so 30 seconds for that and your time starts now. The red arrows are the directions in which the object is moving. Friction should act in the opposite direction. So think in which direction friction should be acting in all these objects. Okay guys, time up. So if I look at the first object there, I can see that the object is trying to move downwards. Friction acts in the opposite direction. So friction should be acting in the upward direction. In the second object, friction is towards the right. The object is moving towards the right. So friction should be towards the left. Third one, object is moving up. Friction should be acting in the opposite direction. So it should be moving down. And the last one, the object is moving towards the left. Friction should be acting in the opposite direction. So it is acting towards the right. So keep in mind, friction always acts in the direction opposite to which the object is moving. So if we summarize friction, friction always acts in the dash direction to which an object is moving. And it's already given to you that that word starts with O. So what is the word there? Friction always acts in the, yes, opposite direction. Friction is a type of force. This is too much easy an activity for you to do, isn't it? Whenever you get friction between two objects, you always get. Think about what I said. When you're rubbing your hands together, what happens after some time to your hand? Yes, it gets hot. It gets heat. Whenever you get friction between two objects, you always get heat. Your hands get hot. You always get heat. Sorry, my bad. And wearing. Wearing after some time, say you start to, especially if it is these parts in the machinery and all, wear and tear happens. So how can you reduce friction? You can reduce friction by using a lubricant. And the most common example of lubricant that we use in car engines to reduce friction is oil. Okay, so that is what you need to know basically about friction. So now we are coming to the last part of this PowerPoint. So this particular topic, mass and weight, is one of the strongest misconceptions students have in physics. Okay, it is an area that always, knowingly and unknowingly, students gets confused with. They fail to notice the difference between both of them and get mixed up with their units, etc. Okay, so we are in our mission to get this right again. So let's see. What we are going to see is the definitions for mass and weight and how can we make the difference between them. So what is mass? Mass is what you're made of. Mass is the quantity of matter you have. So mass is the amount of matter contained in an object. It's always measured in kilograms. Okay, so mass is measured in kilograms. It's not a force, so we never measure it in newtons. Another speciality of mass is because it is what you are made of, it should stay the same wherever you go. See, you're going to America, you're going to outer space, you're going to Jupiter. Wherever you go, as long as you're taking the whole of you with you, as long as you're not going to leave one of your hands or one of your legs here or some other of your body parts here and go, your mass should not change. So ideally or realistically, wherever you go, you take yourself with you. So mass should be a constant. So mass will be the same anywhere you go in the universe, even if it is outer space, it's not going to change. Then, what is weight? So weight is a force. Mass is not a force. Weight is a force. And all of you who are busy writing this down, hold on, listen first and then write. You have the slide, so you can always pause and write things later. So first listen. So mass is not a force, weight is a force. Which force causes weight? The gravitational force of attraction of the Earth. And the unit of unit of weight is newtons. Weight is a scalar quantity, so that is something that's not written separately in the slide, but you can make a note of that. Did I say weight is a scalar quantity a couple of seconds before? No, so that I was wrong. Weight is a vector quantity because it has both magnitude and direction. Weight, what's the direction? Weight always acts towards the center of the Earth. And that means, what am I writing? Towards the center of the Earth. And that means the weight is always acting downwards. So weight is a vector quantity. Mass doesn't have any direction, so it is a scalar quantity. Okay, so this is what weight is. Weight is a gravitational force of attraction acting on an object. It is measured in newtons. It is a scalar quantity. Why do I keep saying it is a scalar quantity? I'm sorry. It is a vector quantity and it always acts downwards. Okay, so the difference between mass and weight. Mass is the amount of matter an object contains. Weight is a gravitational force of attraction on an object. Mass is measured in kilograms. Weight is measured in newtons. Mass is not a force, weight is a force. Mass is scalar, which means it has no direction. Weight is vector, which means it has direction. Okay, so now those who want to copy this down, you can pause the video and then copy it. I'm moving on to the next one. So we are moving on to the last slide. So we said mass and weight are different and we gave quite a lot of differences between mass and weight. So is there a connecting link between both of them? Yes, there is a connecting link between both of them. So say I have an object of mass m with me. I'm keeping it in a place where the gravitational field strength, or in simple terms, gravity, is g. In that case, the weight of the object is given by weight is equal to mass times gravity. On Earth, gravity or gravitational field strength, which is a right thing, gravitational field strength has a value of 10 newtons per kilogram. Accurately, it is not 10, it is 9.81. GCSEs, you can use 10, yeah, that's absolutely fine. But if anyone wants to use 9.81 or 9.8, you're most welcome to do that. Okay, so on Earth, the value of G is 10 or 9.8 or 9.81 Newton per kilogram. So this is why we say weight keeps changing. So previous slide we said mass is constant, but weight is not constant. It depends on G. So if you go to Moon, where the gravitational field strength is 1/6 the gravitational field strength or gravity of Earth, your weight is going to be 1/6 of what you have on Earth. If you go to another planet, depending on where if their gravity is less than that on Earth, you will weigh less there. If the gravity is more than that on Earth, you're going to weigh more there. Okay, and if you go to outer space where there is no gravity, you're going to be weightless. So the best weight loss plan for dieting would be going to outer space. You're going to weigh nothing. I think that will be a really good weight loss plan for me, who always wants to eat and lose weight. Both won't work together, isn't it? Anyway, so coming back to our topic. So you have weight, you have mass, and you have gravity. They are connected together by weight equals mass times gravity. So together with this PowerPoint, there is a very simple sheet on mass and weight. So once you have listened to this PowerPoint, then you can take another 10-15 minutes and then do the PowerPoint. Okay, so what we did in today's lesson is quite basic. For some of you, it might be like, oh, I haven't learned anything new. I have done all these things in year 8, which is really good if you can still remember everything crystal clear, which you had done 2 years back. Amazing, well done, keep it up. Otherwise, this is just a recap. So next lesson, we will be moving on to Newton's laws. So before that, I wanted you to have the concept of force very clear. So that was the purpose of this audio PowerPoint. Okay, so once again, before signing off, I would like to remind you that mass and weight is not the same. Okay, we have seen quite a lot of differences between them. Mass is something that always stays constant. Weight keeps changing. Weight is vector, mass is scalar. Unit of mass is kilograms, unit of weight is newtons. So now you can do the worksheet on mass and weight, and then that should be the end of this lesson. Okay, so see you with the next PowerPoint, next lesson. Till then, bye-bye.